Hi everyone. In this video we're going to be looking at the last bit of chapter 3. It's the last section in the PowerPoints and we didn't really get a chance to go over it in class, so I wanted to look at it here. We're going to be talking about percentiles and what that means for us. And just another bit of data to look at, another sort of computational things that we can look at. Okay, so if we take a look here, just a reminder, we have talked about, in class, we've talked about measures of center and measures of variance. And the reason I did these in different colors is because it's important to think about things going together. So one of the measures of center that we look at are means. And in addition, a measure of variance is a standard deviation. So these two quite often will go together. The mean, usually when you look at the mean, you look at the standard deviation. These two go together. And today what we're focusing on is when we look at the measure of center that is the median, and that quite often will go together with the range and the interquartile range, which is a measure of variance. So don't forget that measures of variance have to do with the spread of our data, and measures of center obviously have to do with what is our data center around? What is that sort of middle number? We also down here will quite often look at the mode, but that's not something we're focusing on at this point. Okay, so let's close that out. So imagine I have some data here. These are the number of chocolate chips. Oops, let me pause this here. These are the number of chocolate chips in 30 different cookies. Okay, so I just wanted to show you this data, and this is the original data, and over on the right I sorted out the number of chips in 30 different cookies. So we'll come back to this in just a second. I want to take a look now at a couple of formulas. For percentiles, we have two different formulas that we're going to be looking at. And I just want to go now through some of the what these letters represent. Okay, so right here, this K represents the percentile. So in other words, like the kth percentile, or sometimes we might see it written as the P of K. So for example, P of 20 would mean the 20th percentile. And percentile simply mean, for example, the 20th percentile means that value for which 20% of your data is below that number, 20% is below, and the other 80% is above, whatever that, and that is your 20th percentile, whatever that number is, depending upon the data you're looking at. So that's a percentile. L stands for it's sort of your locator, and I'll get back to that in a minute. It has to do with which data value it is. N represents your total, as it often does, total amount of data. In this case, we were going to be looking at the 30 cookies, 30 chocolate chip cookies, and times 100 because that has to do with the percentile. And then over here, I just did some algebra. So on this formula, which just takes you over to this one, and it's just solving for a different variable. So if you know the percentile, you then want to find what that data point is. Okay, so we'll be using these formulas. All right, I'm going to close this out and come back to our data. And let's take a look here. Let's start with a question here. So the question is, what is the percentile for 23 chips? Okay, so if you look over here, and I can't really draw on the oh, I can. But right here is the, here's exactly where 23 chips are. Okay, 23 chips. So the question is, what is that percentile? In other words, what percent is below 23 and what percent is above 23? So this is what we're trying to find. So we'll be using this formula over here, okay? So the first thing we need to do is find L. So this is going to be our K, which that's the percentile we're trying to find. L is going to be the number of data points, number of data below 23. Okay, so here's 23. It is the 11th value. That means there are 10 values lower because this is where I sorted it. So it's going, this column is going from smallest to biggest. So there are 10 cookies with less than 23 chips. So 10 is our L divided by N, which is our total data points. We've got 30 down here. You can barely see it, but 30 is down here. All right, 10 divided by 30, and we're going to multiply that by 100. And you can go ahead and do that on your calculator, and you will discover that that equals 33. Okay. Actually equals 33.33, and we just don't have to be that specific. Therefore, it is the 33rd percentile. 23 chips is the 33rd percentile. Or in other words, the way we would write this is P of 33, the 33rd percentile, is equal to 23 chips. That's right there. Okay? All right, let's try another one. Let's close this out and let's open another question here. What is the median number of chips? Okay, well, I'm sure most of you know how to find medians. You've done this before. You would sort all the data. You'd see you have 30, and you know what to do, that you'd find that halfway point. Okay, I know 15 is the halfway point. It's got to be somewhere here between 24 and 24, I guess. Let's see, 15th. Actually between the 15th and the 16th, right? So you can see, you know it's right here, and you know that you would take 24 plus 25 and divide it by 2, and that equals 24.5. You've been doing that for a long time, just like you know how to find means. Okay, but let's just go ahead and take a look at how to do this with this formula. So the median is really the 50th percentile. That's what it is. It means the median is that halfway point. It means 50% of our data is below the median, 50% is above. 50 below, 50 above. Okay, half above, half below. So in other words, what we're really asked to find is P of 50 equals the median, and that's what we're asked to find. Okay, so now we know the K, so we've got to figure out L, which is the number of data points below or above. So we're going to plug in the numbers just to show you how the formula works. K is 50. It's P of 50 times N, which we know again is 30, and we're going to divide that by 100. If you do that on your calculator, you're going to discover that it equals 15. Okay? Now, when L is a whole number, that's a whole number, then what you do is you go to the 15th and the next one and the 16th. Those are the data values you look at. So our 15th data value, here's number 15, is our 24. And our 16th, which is right here, is our 25. And we find that number in between, which is exactly what we just did right here. We would be adding the 24 plus the 25 and getting the midpoint of that, 24.5. Okay, so our median is, just as we knew it was, is 24.5. Okay, or in other words, the P50 is 24.5. Okay, so not so difficult. Let's do one more. Let's go on up here and let's do this one. What is Q1? Okay, so what is Q1? Well, this represents quartile 1, and it's a very special value. It's along the same lines as median, and I bet you can guess what it is. Quartile, it is the top 25%, or the bottom 25%, I should say. It's P25. It is that marker that where 25% of your value is, we know it's probably somewhere in here, where 25% is below and 75% is above. That is your P25. You're in the bottom 25%. That is your first quartile, quartile 1. All right, so again, using the same formula, L is going to equal, we are in the K is 25. Again, our number of data points is 30 divided by 100. And using your calculator, you're going to see that L equals 7.5. Okay. Now, because L is a decimal and not a whole number like the last one, we just go strictly round it up to the next higher value. Even if that were 7.1, you don't follow the rounding rules. You always go up to the 8th number. So 8th number is right here. Here's number 8, straight across, and here it is 20. It is your 20, it's 20 chips. Okay, so P of 25 equals 20 chips. In other words, the 25th percentile, 25% of the cookies will have less than 20 chips. 75% of the cookies will have more than 25 chips. Okay, so I think you'll get the hang of that. Last thing I'd like to do is sort of look at how we display this a little bit. I'm going to go ahead and close that out. And what I've done here is take a look at how we display this. This is something called a 5-point summary and a box plot. A box plot is just a graphical representation of the 5-point summary. Just like we did before, remember, a histogram is a graphical representation of a frequency distribution. All right. So in this problem of our chocolate chips, if we went back to our data quickly, you'll see that our minimum number of chips, right here, our minimum number of chips was 15, and our maximum down here, it's cut off a little bit, but it's actually 38. So I'm going to fill those numbers in. The minimum value was 15 chips. Oops. Minimum value is 15 chips. The Q1 was, we figured that out, was 20. The median we did, that happened to be 24.5 chips. Oops, I wrote this wrong. This should be Q3. Q3, which, as you can probably imagine, is the 75th percentile. It's the top 25%. And I'm not going to go through the exercise of solving that one, but I can tell you that it is 28 here. And our max was 38, as we looked at. Okay, so these are just 5 very interesting points that we look at graphically. So here we making a number line. Here's our maximum value of 38. Here's our minimum value of 15. Okay, this I kind of just sort of made sort of halfway point. This is kind of a mid-range point, just to show you that the median is not necessarily right in the center of it. In fact, our median is over here at 24.5. That's a little closer to the 15 than the 38. So we're just going to draw this line here. And, you know, this is an approximation. Using a graph paper is much more accurate. But here's 24.5. This is our median, right? Then our Q1 is at 20. So here's 15, here's 20. It's maybe right about here. Just approximating. Here's 20, and this is Q1. And then 28 is definitely closer to the 24 than the 38, but it's a little bit farther out. Actually, no, it's not. Up here. Okay. This time it's actually, the spread is quite even. Q3 is 28. Okay, so here is, and then we take this part and we bring in, this creates that box. Okay, and this box, this area in here represents our middle 50%. 50% of the cookies fall right in here. So you can see just visually that it doesn't take up half the space. It's kind of clustered in this area. We have this 38 might be a little bit of an outlier, maybe not fully. We have a way to compute that, but they're a little more spread out here than they are over here on this side. But it's just another visual representation of how to do that. Okay, so in your homework, just to show you quickly, I put the data into StatCrunch, and as you can see from our summary to statistics, we did everything correctly. But just wanted to show you too that you can graph your own box plot right here. You can put your data in there, and I usually click on draw the boxes horizontally because then it matches up. And you can see here that we did it pretty accurately. You can see that the median is in fact a little bit closer to Q3 than it is to Q1. The median is not right smack in the center. It's just a visualization. Okay, and when it says that IQR of 8, that's what we call the interquartile range. I did want to talk about that. The entire interquartile range is the distance from Q1 to Q3. It is the range of Q1 to Q3. So 28 minus 20 is 8. The IQR is equal to 8. And so that's just an important number. It's that middle 50%. All right. So just to recap, when we go way back here, let me close this one down. Just want to recap here. These are our two formulas for finding the percentiles. And here is just a little reminder of measures of center, measure of variance. And this is just another way to find, now you know how to find interquartile ranges, and specifically how to find those different percentages. You now know how to find these values. Okay, so go ahead and finish up homework number 7. Good luck.